definition and its properties. Let's get started. Definition we'll discuss. The definite integral of the form like integral 0 to 1 x power m minus 1 times 1 minus x power n minus 1 dx. This is n minus 1 dx. It is called a beta function. It is denoted by the symbol beta of m comma n. Okay, read as beta of m comma n. That is, we can denote beta of m comma n equal to integral x equal to 0 to 1 x power m minus 1 times 1 minus x power n minus 1 dx. This is called a beta function definition. Let us discuss here few points. The first point is beta function converges. Beta function is converges if both m and n more than 0, which means m is greater than 0 and n also greater than 0. Beta function diverges. Beta function is diverges if m less than or equal to 0 as well as n also less than or equal to 0. Next, this beta function is also called as Eulerian integral of first kind. Here, so this is the definition of a beta function. Integral 0 to 1 x power m minus 1 times 1 minus x power n minus 1 dx. So it is denoted with the symbol beta of m comma n. That could be writing like beta of m comma n defined as like this: 0 to 1 x power m minus 1 times 1 minus x power n minus 1 dx. Here m comma n are positive, then this definite integral is converges. If m comma n are less than or equal to 0, this beta function is diverges. This beta function is also known as Eulerian integral of first kind. Now, so definition is over. So let us discuss about properties. The very first property is property 1, I can say here. So the property 1 is property 1, symmetric property. Symmetry of beta function, which means so beta of m comma n equal to beta of n comma m. This is the symmetric property we need to prove. The proof is given like this. So we'll go for proof. So consider beta of m comma n, which means LHS. So let us take beta of m comma n. So apply the definition of beta function, or since we know that beta function definition is integral x equal to 0 to 1 x to the power of m minus 1 times 1 minus x power n minus 1 dx. Let us mark this is equation number 1. Now we need to prove this RHS as beta of n comma n. To prove this, we need to go for a substitution method. So the suitable substitution here, so I will take this part 1 minus x as my substitution, or let I can say here 1 minus x equal to some y. Let us take equation number 2, some variable y, equation number 2. Okay, from this I required in future the value of x. So 1 minus y equal to x, just keep this one. So 1 minus x equal to y. Now here for 1 minus x, differentiate both sides with respect to x. Differentiating with respect to x both sides. So 0 minus 1 equal to dy by dx. So or else we can write only dx equal to minus d times y. After that, it's a definite integral. Limits will be changes, since I'll talk about here limits. So limits, it's a definite integral. Limits will changes. Limits, lower limit is, so as per equation 1, lower limit is x equal to 0. Just to plug in x equal to 0, when x equal to 0 in equation number 2, substitution in equation number 2 here. Okay, so x equal to 0, 1 minus 0 equal to y. which means y equal to, this is the lower limit of new variable y. Now upper limit, so what is old variable upper limit? X equal to 1. So see here, x equal to 1 is the upper limit for x. In same equation number 2, plug in equation number 2, which means 1 minus 1 equal to y. So from this you will get y equal to 0. Therefore y limits are 1 to, this is 0 to, is it 0? So this is 1. Actually simplification is done wrong, so I'll mark as this is simplification is 1 here. So here this will be 0. So the limits for y are 1 to 0, because lower limit is 0 1, upper limit is 0. Now the next step is substitution of these results, like this one, 1 minus x in equation 1. 1 minus x means y substituting. Next to dx value also we need to substitute in equation number 1, as well as I need x value. So this third one, 1 minus y equal to, I need to substitute as x, which means wherever x is there I have to write 1 minus y. And the fourth one is y limits are 1 to 0. These four we need to substitute carefully in equation number 1. Okay, here limits x equal to 0 to 1 changes with y from 1 to 0. X, I have here x, this x is replaced with 1 minus y. Powers are same. 1 minus x, 1 minus x means y from equation 2. Okay, dx means minus dy. These four substitutions required in equation number 1. So I will add new page. Therefore equation 1 implies, so whose LHS? Beta of m comma n, this is equals to integral y from now 1 to 0. We have x is there, x means 1 minus y, power is m minus 1, multiplied by 1 minus x. 1 minus x we have taken as y, power n minus 1 dx value minus dy. Now rewriting this definite integral with the help of this rule. Since integral we have a to b f of x dx, by definite integral property this could be writing integral minus integral b to h, interchanging limits, upper limit as lower as upper. So by putting here negative sign, f outside is negative sign, f of x dx. When you apply this limit, y 1 to 0 will become now minus integral y from 0 to 1. Interchanging limits, now there is no change in integrand, this could be remain same, n minus 1 times 1 minus y, power m minus 1 negative dy. Now this minus and outside minus both will become positive. Now I will change variable also. Okay, I will rewrite here wherever y is there, y with x from 0 to 1, x power n minus 1, 1 minus x power m minus 1, and dy as dx. I changed variable because of this rule. Integral a to b for any different integral f of x dx, this is equal to integral a to b f of y dy, because this is in terms of y total. Okay, this could be writing now in terms of x. With the help of this rule, nothing will happen. So beta of m comma n, the result will be remain same, so equal to LHS beta of m comma n. Now my RHS, if you look as a power of x, n minus 1, but definition says m minus 1. Okay, multiplied by 1 minus x power, interchanged here constants, which gives beta of n comma m, which means in place of m, n is there, in place of okay n, m is there. So this could be equal to beta of n comma n. So symmetric property is proved. This is called property 1, called symmetric property. Now move on to property 2. Property 2 is beta of m comma n equal to 2 times integral theta from 0 to pi by 2, lower limit is 0, upper limit is pi by 2, sine power 2m minus 1 theta into cosine power 2n minus 1 theta d theta. This is property 2. Now we need to prove that this property using a definition of a beta function. Since We know that as per the beta function, beta of m comma n equal to integral x from 0 to 1. This is a definition, x to the power of m minus 1 times 1 minus x power n minus 1 dx. Let us mark equation number 1. Now we have given here beta of, we need to prove beta of m comma n equal to this integral, definite integral in terms of integrand trigonometric function. But we have started with the beta function with the algebraic integrand. Now how to change this algebra integrand in terms of a trigonometric integrand means by taking suitable x in terms of trigonometric function. How to choose? We have a relation. If you look 1 minus x equal to sine square theta. So let us take sine square. So because we have a relation in trigonometric identity, so 1 minus sine square theta will be equal to cosine square theta in further steps. So here let or consider x equal to sine square theta, because we need integrand also in terms of sine square. That's the reason let us take x equal to sine square theta. So this one let us mark equation number 2. Now differentiate with respect to x. Differentiate with respect to x on both sides. On both sides. So which means here x derivative 1, right side derivative, it's sine square theta, derivative 2 sine theta. Again apply chain rule, sine theta derivative cosine theta. Again chain rule, theta derivative d theta by dx. The next step, cross multiply dx. Dx equal to 2 times sine theta, which is multiplied by cosine theta, again d theta. This is finished. Afterwards we need to talk about limits. So what is lower limit? L dot L stands lower limit. So go to equation 1, choose lower limit. When x equal to 0, plug in equation number 2. So LHS we have 0 equal to sine square of theta. So choose for what value of theta, you will get 0 for the sine function. So theta equal to 0 degrees. So when sine square theta equal to 0 means theta equal to 0 degrees. Upper limit is when x equal to how much from equation 1? It is 1. So equation number 2, plug in equation 2. LHS 1 equal to sine square of theta. So simplify this function. So the solution for theta is here, theta equal to pi by 2, because sine theta equal to 1 or sine square theta equal to 1 means theta equal to pi by 2. Therefore the theta varies, or theta for lower limit is 0, theta for upper limit is pi by 2. Now we need to substitute this x equal to sine square theta as well as dx equal to 2 sine theta cosine theta d theta. Again this theta from 0 to pi by 2 in equation number 1 for further simplification. Let us add one more page. Therefore equation 1 implies LHS beta of m comma n, which is equal to RHS. So we have 0 to 1 will become now theta from 0 to it's pi by 2. Okay, we have here x means sine square theta, but power is m minus 1. So I will be writing sine square theta power m minus 1. Okay, 1 minus x, which means 1 minus sine square theta power n minus 1. We have dx is nothing but 2 sine theta cosine theta d theta. Okay, now simplifying the integrand. So here we have 2 is there in integrand, please write outside. Theta from 0 to pi by 2, 2 times integral 0 to pi by 2 followed with sine square multiply with 2, so which means 2m minus 2 theta. Okay, so here we have a rule, 1 minus sine square theta is nothing but cosine square theta by trigonometric identity, which gives cosine square theta power n minus 1, which is multiplied by only sine theta times cosine theta d theta inside. The next step, make the group of sine functions at one place and cosine functions in again one place, then simplifying. Now So this could be equal to, these two are sine functions, again making one group. So bases are equal clearly, you can add directly powers. Here power is 1, so which means 2m minus 2 plus 1, which gives 2m minus 1 theta. Similar pattern here, 2 multiplied with n, 2n minus 2, here power is 1 is there, anyhow which will be giving, okay, cosine power 2n minus 1 theta data after simplification. Okay, so this is my proof for this second property. Okay, hence the result is proved. Now we will discuss one more property, property number 3 of a beta function. Property 3, P3 I can say, it is defined like this: beta of m comma n, it is defined as beta of m plus 1 comma n. The second term, beta of m comma n plus 1. This is called beta third property. Proof. So here I will prove from RHS to LHS. I will not start from directly definition. So first I will consider right hand side. So my right hand side is, there are two terms, beta of m plus 1 comma n. Again we have beta of m comma n plus 1. Now this could be equal to, for the first term apply definition. Definition is x from 0 to 1, x power m minus 1, which means m plus 1 minus 1, because in place of m we have m plus 1 is there. So let us change here m plus 1 minus 1 multiplied with 1 minus x power n minus 1 dx. There is no change here in second, okay, power, plus again we have second term beta of m comma n plus 1, same definition, again apply 0 to 1. Now this time x power m minus 1 same, but 1 minus x will be changing, n plus 1 minus 1 times dx. Okay, if you see here, plus 1 minus 1 cancel out, again plus 1 minus 1 cancel out. The next step, simplification. This is equals to, so here leftover part, x from 0 to 1 in the first integral, x to the power of m, which is multiplied with 1 minus x power n minus 1 dx. Again in the second integral, the leftover part, x from 0 to 1, x power m minus 1 times 1 minus x power n dx. Now we'll be making as single integral 0 to 1. Okay, not only making single integral, so let us take x power m minus 1 times 1 minus x power n minus 1 outside, make a bracket, because if you look here, power m is there, here power m minus 1, which means here what to do, multiply and divide by x. Okay, so which means, okay, here multiply and divide by x means x power m minus 1 again multiply by x. So here I have to write as x, here I have to write as only x. Okay, again this positive sign, this integral outside, this there is no problem with the 1 minus x power n minus 1 already outside. When it comes to second integral already outside, x power m minus 1, okay, no issues, already we have written outside. Here 1 minus x power n is there, but I need n minus 1, so which means multiply and divide by 1 minus x. So here 1 minus x left, okay, 1 minus x is extra quantity, so you put over here dx. So now if you see here, positive x, negative x both will be cancelled out. In this square bracket only one left, 1 time dx is dx. The next step will be beta of m plus 1 comma n, again plus beta of m comma n plus 1. This is equals to, so we can say here integral x from 0 to 1, x power m minus 1 times 1 minus x power n minus 1 dx. This is nothing but beta of m comma n definition. Okay, now quickly we will discuss proof in fourth property proof in next class. Okay, it is the property is defined like this: beta of m comma n equal to m minus 1 factorial times n minus 1 factorial whole divided by m plus n minus 1 factorial here. So m is both m greater than 0 and n is positive integer. Okay, in this class, so we discuss about definition of a beta function and four properties excluding the proof of fourth property. Only I have given the property, okay, for beta function. Thank you students, thank you for watching. See you in next class.